3y minus 2x equals to 5. X minus 2 equals negative 3y. To make this as a system of equations, you need to first write it as something x, something y equals a number, something x, something y equals a number. It has to be in that format in order to write it as a matrix of coefficient times xy and then the constants. Okay? That's the first step you have to do. Let's see, this, to make the first one look like this, you just have to switch these two around, right? So I'm going to put negative 2, that's what you have, that's negative 2, and that's 3, it's plus, and then 5 is here. Okay? And then for this one, I need to bring the negative 3y here and bring the negative 2 to the other side, right? When you move terms, their signs change, right? So this will be just 1x. It's just x itself says 1 times x. And this one will be what?
3y.
Plus 3y, right? Because this minus 3y, if you move it to the other side, will become plus 3y. Negative 2 moved to the other side will give you 2. Okay? Then you can rewrite this. So that's, this system is equal to that system. Then you can rewrite this as negative 2, 3, 1, 3, x, y equals to 5, 2. Okay? So this is the, this is called the matrix of coefficients. This is the column vector of unknowns and the column vector of constants. Overall, it has the following structure. It looks like a times x equal to b, and you solve this by just multiplying the a inverse. So you multiply a inverse both sides, and you get a inverse of b. So that's how you solve it. Okay. So let's try that. Negative 2, 3, 1, 3. Inverse. We need the inverse in order to solve it in this format, right? How do you find the inverse? What's the formula? 1 over the determinant, which is AD minus BC. This times this, negative 6, minus 3 times 1, which is 3. And then you're to switch the diagonals, so these two switch places. 3 comes here, negative 2 comes down here. And then 3 and 1 should be negated. The off-diagonal ones should be negated. That's the formula for the inverse. Okay, so if you forgot the inverse formula, let me write it over here again. A, B, C, D inverse is 1 over AD minus BC. And then it's DA, these two switch places, and B and C will have to be negated. That's the formula for the inverse of a 2 by 2 matrix. Okay, let's continue. What is that? That's 1 over negative 9, 3, negative 3, negative 1, negative 2. Okay, so that's the inverse. Therefore, what is x comma y? What's x and y? That's the inverse matrix, negative 1 ninth, 3, negative 3, negative 1, negative 2, multiplied by 5 and 2, the column of constants. And then you just have to do the matrix multiplication. Remember, how do you do matrix multiplication? It's across and down, right? So that you have 3 times 5 is 15, negative 3 times 2 is negative 6, so it's positive 9. Negative 1 times 5 is negative 5, negative 2 times negative 2 is negative 4, so it's negative 9. And therefore, when you multiply 1/9 to it, it's negative of 1 and negative 1. And then applying the minus, it's negative 1 and 1. Therefore, you get the value x equals negative 1, y equals 2. That's how you solve this. Now compare this with Kramer's rule. Let let me briefly talk about the Cramer's rule. What's the Cramer's rule? Cramer's rule says X would be taking the matrix of coefficients, and you replace. Okay, so whether you're getting X or Y, the answer is always over the determinant of the coefficient matrix. So let's see, it's -2, 3, 1, 3. And again, -2, 3, 1, 3. And then the numerators are obtained by taking the coefficient matrix and switching out the columns by the column of constants. That's what Cramer's rule says, right? So this first column, if you replace it by 5, 2, you would get 5, 2, 3, 3. And for y, you would switch out the second column, so it would be -2, 1, that's the same. But the right side, the second column, will be 5. That's called the Cramer's rule. I only showed you in the context of a 3 by 3 because it's 3 by 3 and afterwards that makes more sense to use the Cramer's rule, but I still want to show you that it's the same story if you use the Cramer's rule in the 2 by 2 matrix context. Okay? So let's see what you get. It's 15 minus 6, that's 9 on top. We already did this. This is -9, right? This is -1. So that's the x value, exactly the same as this one, right? And then this is -4 minus 5, so it's -9. This is also -9, so it's fine.
Are you going to specify which one we have to use?
I mean, the question said to use inverse, so you need to know how to use the inverse. Yeah. But I could also give you a separate question which requires Cramer's rule, so you should know both.